number 6, it tells us that we want to complete the diagrams using each of them to find 253 times 31. So if I look at both of my diagrams, they're both multiplying 253 times 31. They just have their breakdown different. Okay, this one has it broken down into more partial products on place value. So we'll just start with the top one. 253 times 30. Now where'd they get the 30? Because these were our numbers, 31. So here's the tens place and the ones place. And we can use quick math with multiples of 10. Multiply the whole number parts that you see. 3 times 3 is 9. 3 times 5 is 15. You carry your 1. 3 times 2 is 6, plus 1 is 7. Okay, so we know that the top part, we got 759, and then how many multiples of 10 were we dealing with? Just the 1. So our top part is 7,590. Okay, if we look at the bottom part, 253 times 1, well, that's just 253, isn't it? Okay, and then if we add both of those together, we would have 0 plus 3 is 3. 9 plus 5 is 14, carry the 1. 5 plus 2 is 7, plus the 1 is 8. And 7 plus nothing is 7. So we would have 7,843 if we used the top diagram. So I'll just write that over here, 7,843. That's what we got when we used A. Okay, when we move to the next diagram, it's still representing the same number, 253 times 31. It's just broken down differently. So if we multiply each of these partial products, we would have 200 times 30. So we know now that we can use multiple of 10 math, multiply the whole number parts that I see. 2 times 3 is 6. And how many multiples of 10 altogether? 1, 2, 3. Okay, in the next box, 50 times 30. Quick multiple of 10 math, multiply the whole number parts that I see. 5 times 3 is 15. And how many multiples of 10? 1, 2. And then 3 times 30, multiple of 10 math. 3 times 3 is 9. And how many multiples of 10? 1. Okay. If I move to the next one, any number multiplied times 1 is just going to be itself, isn't it? So 200 times 1 is 200. 50 times 1 is 50. And 3 times 1 is 3. And if we add these up, we would have, if we added the top row, we would have 6,000 plus 1,500. 6,000 plus 1,500. So that's 7,500. And then 90 more would give me 7,590. And then on the bottom, 253. These look like the numbers that I multiplied a minute ago. Let's just double check. We'll add them together. 0 plus 3 is 3. 9 plus 5 is 14, carry the 1. 5 plus 2 is 7, plus 1 is 8. And 7 plus nothing is still 7. So look, it doesn't matter how we broke it down, it's still going to be the same outcome because the place values, we're multiplying place values. We just broke this one down into more partial products. Okay, so how were the methods the same? They both used decomposing boxes, didn't they? And how were they different? This one just broke it down into 2 partial products, and this one broke it down into 6 partial products. Okay? All right, what is the volume of this rectangular prism? Well, let's think back to previous units that we've done. We know that volume is equal to length times width times height. And when we're dealing with volume on a piece of paper, because it's not 3-dimensional, We look at length as going this way, width is how deep it goes into the page, like if we laid it down, how deep it would go into the page, and then our height obviously is up and down. So our length for this prism is 40 centimeters. Our width, or how deep it goes into the page, is 60 centimeters. Now, they give that to me twice. So be careful when you're doing tests. Just because they give you 4 numbers, always think, hey, did they just throw an extra number in there? Yeah, that's just another representation of showing how deep it goes into the page, what the width is. We don't use both of them. Okay, and then our height is 80. Now, luckily we have learned multiple math. So we know that if we're dealing with multiples of 10, we can do quick multiple math. 40 times 60, I multiply the whole number parts that I see. 4 times 6 is 24. And then how many multiples of 10 did I use? 1, 2. And then we still have to multiply that outcome times the height of 80. And again, I can use quick multiple math. Multiply the whole number parts that I see. 24 times 8. You can go to the side to do that. 8 times 4 is 32. Carry your 3. 8 times 2 is 16, plus your 3 is 19. So 192. And then how many multiples of 10 were we dealing with? 1, 2, 3. So when we're dealing with multiples of 10, it really saves us some time, doesn't it? It saves us a lot of time when we know that multiple of 10 math. Okay, now, my answer's not complete yet. We were dealing with volume. Don't forget, when you're dealing with volume, you're going to have to label. We were dealing with centimeters, and anytime it's volume, volume has length, width, and height, so it's 3-dimensional. So we're centimeters cubed with the 3. So always remember to label your final answer with your units and whether it's 2-dimensional or 3-dimensional. So volume is always cubed for 3 dimensions. Okay. Find 315 times 43 using partial products. Okay, there's 2 different ways I could do this. 315 times 43. 3 times 5 is 15, so I carry my 1. Now, if I'm using partial products, do I carry? Oh, I don't carry when I'm using partial products, do I? When I'm using partial products, I have all of my pieces individual. So 3 times 5 is 15, and I'll just put that over here, 3 times 5. That's the little expression. And then 3 times 1, but if we're doing partial product, this isn't just a 1, is it? It's in the tens place, so it's 10. So 3 times 10 is 30. And then finally, we have 3 times this number, but if we're using partial products, it's not just a 3, it's 300. So 3 times 300 would be 900. Okay, and those are our partial products using the 3. Now we're moving to the next number. Now this number's in the tens place. So if I'm using partial product, this is a 40, isn't it? So I would be multiplying 40 times this number first. So 40 times 5, and it's just a 5 because it is in the ones place, so it's just a 5. Multiply multiple math. Multiply the whole number parts I see. 40 times 5 is 20. And then how many multiples of 10? It's the 1. And then I would move on. I'm still working with this partial product, so it's place value. This is 40. And the 1 is in the tens place, so it'd be 40 times 10. Quick multiple math. 4 times 1 is 4. And then how many multiples of 10? 1, 2. And then finally we have 40, remember because we're doing partial products, times, this is in the hundreds place, so 40 times 300. Multiply the whole number parts that you see. It's 12. 4 times 3 is 12. And how many multiples of 10 were we dealing with? 1, 2, 3. 1, 2, 3. And we would have all of our partial products and we would add them together. So 5 plus 0, 0, 0, 0, 0, we still have 5. Now we'll move to the tens place. 1 plus 3 is 4, plus 0, 0, 0, 0 is still 4. Then we'll move to the hundreds place. Doesn't have any. So 9 plus 2 is 11, plus 4 is 15, and I would carry my 1. 2 plus 1 is 3, and 1 plus nothing is 1. So using this partial product method, we say that our product is 13,545. Now, we know that there's another partial product method using the decomposing boxes. So if I decomposed the number 315, I would have 300, and then what's in the tens place? Just a 1, so I would have a 10, and then what's in the ones place? A 5. Okay, so I would have it, the top number decomposed, and then the bottom number. If I decompose the bottom number, I have 40, because that's in the tens place, and 3. Okay, and now what goes in each box? Well, what goes in each box is a partial product. So 300 times 40, quick multiple math, 3 times 4 is 12, and how many multiples of 10? 1, 2, 3. 10 times 40, quick multiple math. 1 times 4 is 4, and how many multiples of 10? 1, 2. 5 times 40, quick multiple math. 5 times 4 is 20. How many multiples of 10? Just the 1. All right, and moving to our bottom row, 300 times 3, quick multiple math. 3 times 3 is 9. How many multiples of 10 was I dealing with? 1, 2. Next partial product, 10 times 3. Well, we can do that quick, can't we? 20, 10, 20, 30. So we know that's 30. And then the last box, partial product, we just know from our math facts that 5 times 3 is 15. Now let's look at my boxes here. Well, the first thing I notice is, do I have all the same partial products? Yeah, I have all the same partial products, don't I? Because I'm still multiplying the same numbers. I'm still multiplying 300 times 40, no matter which way I go, and so on. So it doesn't matter if you do partial product this way or if you do partial product this way. You're still going to end up with the same number, 13,545. And we can check that. 12,000 plus 400 is 12,400, plus 2 more hundred is 12,600. So that's what was on top. And then if we find what's on bottom of our partial products, we have 900 plus 30 is 930, plus 15 more is 945. And if we add the top and bottom together, we get 0 plus 5 is 5, 0 plus 4 is 4, 6 plus 9 is 15, so I'd carry my 1, 1 plus 2 is 3, and 1 plus nothing is 1. So if I do this partial product, I get 13,545. If I use a decomposing box to get partial products, I still get 13,545. So either way, if it just says partial product on the quiz, I don't care which way. You could use either method, whichever one works best for you. That's why we learned so many methods. Okay, number 9. Explain how the drawing shows 2 divided by 5. Whoa, we're having to draw way back on this one to way earlier in the year. Just like on when we take that ACT Aspire, we have to remember everything from all year. So let's pull back. We always looked at these things like sandwiches, didn't we? So up here we have 2 sandwiches. 2 sands. All right, and if I look, each of those sandwiches was divided into 1, 2, 3, 4, 5. So it's all divided into fifths. So I have 2 sandwiches divided by 5. So that's how it represents 2 divided by 5. Now, the next question, part B, is going to ask you, explain how the picture shows 2 over 5. Well, we know, well, just a minute. We know my computer stopped. It's trying to reload the page. Just a second, guys. Oh no. Just a minute. Let me get way back down to this unit. I don't know what happened. There it was. Okay. So, how do I know? Well, I know that when I read them, if I read this one from left to right, it says 2 divided by 5. And I know that this bar is nothing but a division symbol. So if I read them both aloud, they would both say 2 divided by 5. And this also says 2 divided by 5. Well, this board's just going crazy on me now. Okay. Whoa, now it's really going crazy. Okay, number 10. Here is Elena's calculation using the standard algorithm. What product does the 369 in Elena's calculation represent? Well, I'll go and I'll find the 369. Well, we know that when using standard algorithm, the reason I have 2 rows is because I'm multiplying my top number times 2 numbers. So 2 numbers on bottom, 2 rows. So the 369 represents when I multiplied 3 times 123 on top. And then part B says, what does the product 2,460 represent? Well, we know that using standard algorithm, the second row is where I multiply the second number times everything on top. So the 2,460 represents me multiplying 2 times 123. Okay? Now, part C. Use Elena's method to calculate 312 times 33. Well, Elena just used standard algorithm, didn't she? So we would have 312 times 33. 3 times 2 is 6. 3 times 1 is 3. 3 times 3 is 9. Remember, we multiply each number times each number on top. Now, we're moving to our second number in the tens place, so we're going to be in the second row, and we need our actual math calculation to start under the second number in the tens place. So we're going to put a placeholder 0. 3 times 2 is 6. 3 times 1 is 3, and 3 times 3 is 9. And we already knew that, didn't we? Because we just calculated it right there. And then we add them together. 6 plus 0 is 6. 3 plus 6 is 9. 9 plus 3 is 12. Carry your 1. 1 plus 9 is 10. So if we use Elena's method, which was standard algorithm, we get 10,296. number 11. Find 317 times 3 using standard algorithm. Well, this is a simple one, isn't it? We're just going to have one row because we're just multiplying it times one number. 3 times 7 is 21. Carry the 2. 3 times 1 is 3. Plus 2 is 5. And 3 times 3 is 9. So I get 951. And then part B says, describe how your calculation shows the 2 tens from 3 times 7. Well, if I look at 3 times 7, I know I got 21. So that's how my 2 represents the tens from 21. Because if I write the number 21, what number is in the tens place? The 2. So in my calculation, that's how the 2 represents the tens from my 21. It's all about place value. Okay, number 12. Find the value of 562 times 34 using standard algorithm. We always start here. 4 times 2 is 8. 4 times 6 is 24, so we have to carry our 2. 4 times 5 is 20, plus the 2 is 22. Now, don't forget your placeholder 0. You're starting to work with that second number in the tens place, so your actual math calculation needs to start under the second number in the tens place. So put that placeholder 0. 3 times 2 is 6. 3 times 6 is 18. Carry my 1. 3 times 5 is 15, plus the 1 I just carried is 16. I was multiplying times 2 digits, so I have 2 rows. So I add together. 8 plus 0 is 8. 4 plus 6 is 10. Carry the 1. 2 plus 8 is 10, plus the 1 is 11. Carry my 1. 2 plus 6 is 8, plus the 1 that I carried is 9. And see, nothing plus 1 is 1. So using the standard algorithm, I get 19,108. Use the standard algorithm to calculate 726 times 53. 3 times 6 is 18. Carry your 1. 3 times 2 is 6, plus the 1 that you carried is 7. And 3 times 7 is 21. Working with that second number in our second row, so placeholder 0 so that our actual math calculations start under the second number in the tens place. 5 times 6 is 30, so I'd carry my 3. 5 times 2 is 10, plus the 3 that I carried is 13, so carry my 1. 5 times 7 is 35, plus the 1 is 36. And then I add together. I have 8 plus 0 is 8. 7 plus 0 is 7. 1 plus 3 is 4. 2 plus 6 is 8. And nothing plus 3 is 3. So using the standard algorithm, I get 38,478. And then part B says, label my diagram to match my calculation. Well, this is just a decomposing box, isn't it? And since my decomposing box only has one box going this way, that tells me that they didn't break that number down at all. They just left it as 726. But my second number, I see 2 boxes. So that tells me that they broke it down. 5 is in the tens place, so they would have broken that into a 50. And then 3 is in the ones place, so it would just be a 1. And if I multiply, I should get the same thing. Now I'm getting partial products in my decomposing box. Multiple math. I can do 726 times 5, because those are the whole number parts that I see. 5 times 6 is 30, carry the 3. 5 times 2 is 10, plus 3 is 13, carry the 1. 5 times 7 is 35, plus 1 is 36. So how many multiples of 10 was I dealing with? Just the 1, so we add 1 here. And do we see 36,300 anywhere over here? Yeah, well that matches up right there, doesn't it? So 36,300 is my partial product for my top number. And then my bottom number, partial product, I would have 726 times 3. 3 times 6 is 18, carry the 1. 3 times 2 is 6, plus the 1 is 7. And 3 times 7 is 21. Do I see this number over there anywhere? Yeah. That's what I got when I multiplied my first number times 726. I got 2,178. So if I add these together, I should still get this number, shouldn't I? So 0 plus 8 is 8. 0 plus 7 is 7. 3 plus 1 is 4. 6 plus 2 is 8. And 3 plus nothing is 3. So it doesn't matter. We use standard algorithm there, and then we just filled in our decomposing box, which is just broken down into place values. Okay, next one. Y'all did really well on this when we did this in class. Remember our birdhouses? Okay, the recommended dimensions of a birdhouse for a yellow-bellied sapsucker are 13 centimeters by 13 centimeters for the floor and a height of anywhere from 31 to 38 centimeters. What's the smallest and largest volumes for these birdhouses? Well, we know that volume is equal to length times width times height. And for our birdhouse, it tells us that the floor is 13 by 13. So that would be our length and width of our birdhouse, 13 by 13. And then the height, they say, can be anywhere from 31 to 38. So we'll start with the 31 because they want the smallest and largest volumes. So we'll start with the 31. And we will do this in parts, 13 times 13. That sounds like an unlucky number, doesn't it? 3 times 3 is 9. 3 times 1 is 3. I'm working with the tens place, second number, second row. Don't forget your placeholder 0. 1 times 3 is 3. 1 times 1 is 1. And then I add together. So I have 9 plus 0 is 9. 3 plus 3 is 6. And nothing plus 1 is 1. So the length times width, the floor of my birdhouse will be 169. And then I have to multiply that times the first height that they gave me. So 169 times 31. 1 times 9 is 9. 1 times 6 is 6. 1 times 1 is 1. Placeholder 0, working with that second number in the tens place, so we need to start our actual math under the tens place. 3 times 9 is 27, carry your 2. 3 times 6 is 18, plus 2 is 20. 3 times 1 is 3, plus 2 is 5. And then we add together. 9 plus 0 is 9. 6 plus 7 is 13, carry the 1. 1 plus 1 is 2. And nothing plus 5 is 5. So the low value, if we do the lowest height, the smallest volume will be 5,239. And don't forget, we're doing volume, so we're dealing in centimeters, and since it is volume, it will be cubic centimeters. Okay, now we're supposed to be finding two answers because it wanted to know the smallest and the largest volume of the birdhouse. So the next number that it told us was 38 for the height. Now volume is still going to be length times width times height. And they didn't change the length or the width, did they? So we still have 13 times 13, but our height changed. Now it's 38 instead of 31. Okay, so right here, 13 times 13. Well, I don't have to waste time doing that math again, do I? Because I did that right here. So I know this part is 169. So all I have to do is the times 38 part. Okay. All right, so if I have 169 times 38. 8 times 9 is 72, so I carry my 7. 8 times 6 is 48, plus the 7 is 65, 50. Hang on, I'm getting ahead of myself. 169 times 38. Okay. 8 times 9 is 72, carry my 7. 8 times 6 is 48, plus 7 is 55, so carry my 5. 8 times 1 is 8, plus 5 is 13. And then we placeholder 0. 3 times 9 is 27, carry my 2. 3 times 6 is 18, plus 2 is 20, carry my 2. 3 times 1 is 3, plus the 2 that I carried is 5. And then I add together. 2 plus 0 is 2. 5 plus 7 is 12, carry the 1. 3 plus 0 is 3, plus the 1 that I carried. And 1 plus 5 is 6. So the largest volume for my birdhouse would be 6,422. But don't forget, we're dealing in volume. It's going to be centimeters cubed. Okay, it's three-dimensional, so we will be cubed. Length times width times height.